Hello and welcome to another exciting Breakfast with Unity. I'm your host Max Moreau, and we're going to be doing some very basic quote-unquote fog of war. So, fog of war, as far as I know, and please correct me if I'm wrong, I think that term actually was originated by Blizzard when they made Warcraft. I could be wrong about that. There were, of course, games that had the fog of war concept before that, but I don't think that it actually had bore that name publicly until Warcraft, at least Warcraft 2. They might have said they definitely had fog of war in Warcraft 1 as well, but I'm not sure if they actually called it as such. So what we're going to be doing though is a little bit more basic than the map reveal style of fog of war. It's going to be one where this is just a unit reveal, and this one's going to be based on line of sight. So this is more what they do in Diablo 3. That's part of the reason I'm doing this episode, is we're going to probably crib this into Escape at a later time. It's actually very simple to do, that's why it's perfect for a Breakfast with Unity. So the basic concept is, and I'm going to just start up setting up the scene while I say this. The basic concept is we're going to be hiding objects if they can't raycast to the player. It's a pretty simple solution to the problem. I'm just going to set up a plane, and I'm going to just... what's the easiest way to get going here? Obviously, first-person control is not going to do so well here. What do we have for movement? Move. I guess we could... You know what? I'm actually just going to base... What did I do? Oh, okay. I hope it wasn't anything bad. Did I do anything? Hold on. I'll check at the end of the episode. What are we doing? So I'm going to actually... I originally just created a completely separate thing. I'm going to actually switch to click to move and create a copy of this. That way we can pretend that it's a click to movie game. So I'm going to call this line of sight fog of war. No. So in this one, all we have is just a cube that we can move around. If we click, it just goes to where we click. And we're just going to put up some enemies and stuff, and maybe make the area a little bit bigger. I don't know. We'll figure out what we're doing. And by enemies, this can be super basic. We're just going to create a wall. We're just going to create one more wall. So we're just going to create a cube. We're going to put it someplace where we can see it in the scene. Where is it? There it is. Where's our camera? There's our camera. So I'm just going to rotate this 45 degrees and make the Z thing higher. And we're going to make this Y like 3 or something. So we have a nice little wall here. And I'm going to bring it in so that enemies can kind of pour around it and stuff. So, what we've got is, for our enemies, I'm just going to crib from, I'm just going to make spheres, actually. And we're just going to create a sphere, 3D object. And we're going to use physics, follow position physics. We're going to put this on the sphere. And we need to give it a target transform. Oh, dang it. Yeah, we'll just pre-populate these guys. So I'm just going to create a few spheres and throw them behind this wall. And they're all going to try and get to the player. So we're just going to dupe these spheres. Actually, I'm going to, dupe them. We'll spread them out a little bit. These guys are going to be physics-based. They automatically have... they automatically got a rigid body because follow rotation physics requires that. We did that in require component. So we probably could put them all... Actually, let's just find out what happens if we put them all in the same place. If I hit play right now, what do we get? They all bounce out. Okay, that's not optimal. Let's just spread them out a little bit. They'll have null reference exceptions because we didn't tell them to follow the player just yet. So there's our spheres. The two of them will pop out, whatever. And we're just going to give all of these the player to follow, and let's see if they actually will do it. So it looks like they're trying to get to us, and this is actually not a perfect example here because we can't really see them when they're behind that wall anyway. So let me actually move the player over to the left here, and we're going to make the wall kind of more centralized so that we can see clearly what's going on. Oh, this is 35. I wanted 45. There we go. That'll be nicer. So if we hit play now, there we go. We can see all the enemies. Whoa, what happened to the player? What was that? Move to click location. What happened there? Why is he all freaking out? When he was here, how did it go? What has happened? Okay. Got it. Figured it out. So, I didn't move the player. I moved his cube. That was the problem. So we need to set these Z and X values to 0, and then we're going to move the player itself. Okay, yay. That was scary. So we hit play. Okay, everything's fine. Everything's good. All right, cool. Why did he start moving immediately? If I hit play again, does he do that? Why is he moving immediately? Oh, he moves to 0 originally. Interesting. That's a bug in our click to move. I'm not going to worry about that too much just yet. So now let's actually do what we're doing for this episode. So, as I said, it's pretty simple, so I'm not too worried about the time that we've spent so far. We're going to create a C# script. We're going to say, what's the best description for this? Again, I like to use descriptions of what they do rather than like Fog of War or something. Though I guess that's not a bad case in this case. Line of sight rendering is what I'm going to call it. All right. And what we're going to do is we're going to have a I don't want to write this up. We're going to just use the player. We're going to tag them as a player, and we're going to do this by tag. So public string viewer tag is what I'm going to call it, and I'm going to default this to player. And what we're going to do is very simple. Oh yeah, we're going to have one more thing here. Public layer mask equals -1. This is in case you need to not block things in certain cases, which we will actually need even in this very basic example. So so all we're going to do is if physics.raycast, we're going to go from transform lowercase dot position. We're going to go we need the player position, so let's do that. If we're going to need a private game object. Now let's do transform player. Let's do game object. Transform is actually what we need, but game object is what we get out of some other things, so I'm just going to use game object. So so if player equals no, why do you do this to me, player? Oh yeah, I can do undo. I need to remember that. Player undo equals null. Then we will do player equals get game object dot get no. Oh yeah, game object dot find game object with tag viewer tag. I'm going to save this. Maybe it will start playing with me better. Maybe it's because this is not finished. So, so all we're going to do now is player dot transform dot position minus minus transform dot position. So this is our position here. This is the ray to the player, I think. I might have to flip those terms. As I said, I always get that wrong. You've seen me get it wrong on so many episodes. I try not to put point attention to it, but in the morning, it's just not happening. Usually I have Jeffrey to tell me which one's right. So, what are we doing? So, what are we going to do else? We don't care about distance. We don't care about hit info. Oh, we do care about hit info. Yeah. So we're going to need hit info, and we should also do the layer mask. So we're going to need hit info, distance, layer mask. So hit info, we're going to do out hit. We don't have that yet. We will make that later. That one's not their fault for not auto-completing. Distance, wait, was it hit and then distance? Yeah. Math f dot infinity and layer mask. So, what we're going to do now is, do we need the hit information? Yeah, we do. If hit dot game, let's actually make that. I forgot it. That's my fault. Raycast hit. So if hit dot hit dot game object, no, collider dot game object equals player. Is this just me, or is it just is just Monodevelop having a bad day? It is showing the screen, right? Okay, good. So if we hit the player, then what we do is we do renderer dot enabled equals true, and then else renderer dot enabled equals false, and then finally, if we don't hit anything, then we will say renderer dot enabled equals false. So if we save this and put this onto our spheres, so I'm just going to select all the spheres and add component line of sight rendering, and I'm just going to go with that and see what happens. So we're going to hit play, and we can't see the units, but they are actually there. And if we go around this, we can't see them still. Where are they? Let's see what they look like. So they're definitely there. They're all around us, but we don't know. So that's probably because we're probably raycasting in the opposite direction that we should be. So let's go ahead and flip these two terms. All right, let's see how this goes. So if we click down here, still nothing. That's great. These guys like through the ground right now. They're definitely in a position where they could raycast us. Should be able to see at least one of them, even in like the most extreme case. All right, this guy is tagged as a player. Right? Oh, maybe he's not. Oh, that's a problem. So we tagged this. This is the player, but this is also so. The player doesn't have a collider on him. So so what we need to do is if the hit collider game object equals player. So what we need to do is I'm going to move the collider up one level. We're just going to copy this, copy component, paste component values, component is new, and yeah, we'll grab that, and I guess we don't need anything else. We'll just do that. And so now this is the actual player. Now we're going to find out that I've still got things backwards, probably. Yep, looks like it. Let's do one more where we flip these back to the way they should be. Probably, hopefully, maybe this will work. Please work. Let's hit play, and there they are. We can see them. So now we've got a couple problems here, like enemies obscure other enemies, which looks really dumb. So we're going to actually use that layer mask to good effect. So I'm just going to put all these spheres on a layer. We're going to call them... Do we not have an enemy layer yet, really? That's not something that showed up in a show at some point. All right, add layer. We're going to call them enemies. And we're going to throw all these guys into the enemies layer. And then the player is going to be on the player layer. Yeah, go ahead and change the children. And what we're going to do finally is we're going to take all these spheres and we're going to change their layer mask to, we only care about so we want actually everything, but we don't want to be blocked by other enemies. So if we hit play now, we can go over here and there's our enemies. They no longer block each other. And if we hide ourselves behind a wall, we can cheat because we can go through walls in this particular example. We can do that, and you can see the enemies now appear. So this is how Diablo 3 does their enemy visibility checks. Very simple. And yeah, so hopefully this will be helpful to someone on a project. So I'm gonna go ahead and save project. And so thank you for watching this morning. Really appreciate it. If you have any questions, please email me, pushypixels@pushypixels.com. This episode is actually due to questions that I received from a viewer, so please email me. We do stuff. And you can also tweet me at Drakfire. That's DRAKFYRE. Please donate to Cooking with Unity, cookingwithunity.com/Patreon. Really, really appreciate your support. Thank you very much. You guys have a great one. And have a great weekend. I will catch you on Monday with another Breakfast with Unity and another episode on Scape. See you then.